Putin's superweapon under fire as experts raise fears over radioactive emissions during flight. Putin's Skyfall nuclear missile to leave a radioactive trail across vast distances in the sky. Russia's airborne reactor in the sky, as Skyfall's propulsion design triggers fresh safety concerns. Inside Skyfall, the missile that draws air through a nuclear reactor to generate thrust. New analysis by the war zone detailed how Russia's Skyfall nuclear cruise missile may operate, offering fresh insight into the secret of weapon. MIT researchers concluded the Burevestnik likely uses a direct cycle nuclear propulsion system rather than a conventional engine design. The finding raised new questions about whether the missile releases radioactive material during flight and normal operation. As per the study, the weapon may be far more environmentally hazardous than previously understood by observers. Researchers Hekla and Kemp analyzed open-source data on size, speed and engine design, according to TWZ. They said the missile marks the first suspected sustained flight of a nuclear-powered aircraft-type system. Russia revealed the Burevestnik program in 2018 as one of President Putin's flagship superweapons projects. The project followed decades of failed US and Soviet experiments involving nuclear-powered aircraft concepts. Previous tests included US Project Pluto and Soviet-era airborne reactor experiments with similar ambitions. Several reported test incidents since 2017 were linked by experts to the missile program and its development. A 2019 explosion near Nanoxa killed Russian scientists and triggered radiation spikes in nearby areas. Missile length estimated at 31 feet, 9.5 meters, making it comparable to a small aircraft-sized weapon. Wingspan approximately 18 feet, 5.6 meters, according to estimates cited in the analysis. Estimated speed, Mach 0.75, indicating a subsonic flight profile focused on endurance rather than speed. Likely engine type, a direct-cycle nuclear turbojet system powered by an onboard reactor. Airflow passes directly through the reactor core, where it is heated before producing thrust. Result, propulsion generated by radioactive superheated exhaust expelled from the rear of the missile. Air is drawn into the missile and passed directly through the nuclear reactor core for heating. A compressor forces air through narrow channels surrounding the reactor's fuel rods. Fission heat superheats the air before it is expanded to create powerful rearward thrust. The superheated airflow exits through a nozzle to generate continuous propulsion during flight. No sealed coolant loop is used, meaning radioactive materials are not fully contained within the system. This design makes the system's engine compact, but also potentially highly contaminating, according to the report. Direct cycle system, air passes through the reactor core and exits as potentially radioactive exhaust. Indirect cycle system, a sealed coolant loop keeps radiation contained inside the reactor structure. The direct system enables a smaller missile design, but may release fission particles into the atmosphere. Researchers warned the exhaust may contain argon, krypton, and carbon isotopes generated by reactor activity. MIT researchers said the system would likely produce a radioactive trail throughout sustained flight operations. They said long-duration cruising would increase radiation leakage risks and accelerate reactor wear. Experts warned corrosion inside the reactor core could generate additional contamination over time. Former arms control officials said the design combines low speed with relatively high trackability. They argued it offers range advantages but weak operational stealth and limited overall military value. An investigation has exposed how the EU machinery kept feeding Russian missile makers. EU industrial exports continued flowing into Russia despite sanctions. Customs records reviewed by Kiev Independent and Irpi Media revealed a sanctions bypass network, documented trade routes evading restrictions. Records showed EU-made industrial machinery reached Russian defense-linked plants via Turkey, used as a third-country transit hub. Those plants produced specialized metal alloys used in missiles, fighter jets, and weapon systems, key inputs for military production. Investigators said the case showed Russia's war industry still depended on Western technology, despite broad export sanctions. The shipments were traced to facilities controlled by a family linked to Russian giant Rostec, a state-powered defense group. Recipient plants were controlled by Nikolai Timokhin, son-in-law of a top Rostec executive, connected to Russia's defense industry network. Timokhin's companies supplied metal alloys to more than 40 Russian defense manufacturers, spreading material across the military sector. Ukrainian intelligence said one of the plants produced components used in Russia's Kh-101 cruise missiles, which have been widely employed in long-range strikes against Ukraine. The same missiles have been used in repeated strikes on Ukrainian cities during the war, including long-range attack campaigns. The investigation found the plants also served firms building air defense missiles and jets, expanding military production uses. $5 million worth of EU-made industrial machinery shipped in 2023 to 2024, high-value exports identified in customs data. CNC lathes, heat treatment furnaces, hydraulic presses, precision equipment used for advanced manufacturing. Machinery originated in Italy, Germany, Spain, and Czech Republic, sourced from multiple European industrial hubs. Shipments were delivered to AMR and SMK metallurgical plants, Russian industrial sites linked to defense output. Experts said the machinery represented critical components of modern metal production processes. EU sanctions barred Russian companies from buying the restricted equipment directly, report, forcing indirect procurement routes. Investigators said the shipments were instead routed through Turkey-based Red Wing Metal, a middleman entity. The company was created after Russia's full-scale invasion of Ukraine in 2022, emerging during sanctions expansion. Customs records showed Red Wing delivered the machinery to Russia during 2023 and 2024, completing final delivery chains. 40% owned by Dutch national Alexander Tattersall, minority stake held by a Dutch businessman linked to the network. 59.9% owned by Turkish lawyer Vasil Cengiz Soylemezoglu, majority control held through a Turkey-based legal entity structure. Tattersall previously worked with companies selling AMR products in Western markets, indicating prior involvement in international industrial trade. More than missile components, investigation extended beyond core weapons production systems. Customs records also showed that EU-manufactured shipbuilding equipment continued reaching Russian recipients despite existing sanctions. The equipment included anchors, winches, ventilation systems, and wastewater technology, naval support infrastructure. Records indicated the goods were installed on Russian Navy vessels under construction, military use confirmed in data. One of the ships identified in the data was the Mikhail Kalashnikov, a Russian naval vessel under construction. Shipbuilding equipment valued at approximately $1.3 million, estimated value of naval supply shipments. Anchors, mooring winches, ventilation fans, core shipbuilding and engineering components. Onboard wastewater treatment systems, marine infrastructure equipment for naval use. Sanctions experts said the shipments appeared to match goods banned under EU restrictions, potential violation of export controls. The European Commission said combating third-country sanctions evasion remained a priority, official position on enforcement. Experts said the companies involved could face future sanctions or legal scrutiny, possible regulatory action. The case also raised questions about the role of EU nationals in the supply network, linking individuals to global trade channels.